Hi, welcome to the video solution of an Edexcel past paper. This is Edexcel IAL Physics, Unit 2, January 2019, a second and last video of this paper. So let's start. Question number 15, the photograph shows a typical side-on view of a galaxy. The galaxy is rotating around an axis through its center. Okay, this is a picture galaxy and it is rotating around the axis. So the light observed from the galaxy include an atomic line spectrum for hydrogen. Explain how an atomic line spectrum is formed. So this is a general and most typical question of Unit 2, and they talk about why do we have a line spectrum, sometimes emission spectrum and absorption spectrum. So almost all the time we have some key points or key statement to write. So generally, because this is a general concept of a line spectrum formed by an atom, so you can include hydrogen or just in general atom. That atom contains a discrete energy level, and when electron remains in any energy level, so these are the energy levels. When electron in any of the energy level, it does not emit or release energy. Only if electron jumps from lower to higher, that means this electron needs to absorb energy. So that's we say that when atom absorb energy from surrounding, then the electron become excited and it goes to the excited state, and after some time the electron in excited state returns to the ground state. It depends on second or third, so it's all depends on nature of atom. When electron jumps or returns to the ground state, it releases energy, and this energy we see as a spectrum. And what type of energy is going to be released? It depends on energy difference between these two energy levels in which we have a transition. And of course different atoms have a different levels of transition, so that's why we have a unique or distinct line spectrum for every atom. So that's how you can explain. Part B, it was found that the wavelength of one line of a spectrum depends on the distance of the source of the light from the axis of rotation of galaxy. The photograph below shows how distance from the axis affect the wavelength of this line. Okay, so we have a center origin. As you go distance above, so more the distance, you see that the wavelength is increasing. So from center, this is the portion where the wavelength is slightly more, and this is the wavelength slightly less. Explain why the wavelength corresponding to the top of the line is greater than the wavelength corresponding to the bottom of the line. Indeed, because galaxy is rotating, that means it is moving with respect to observer. When something is moving with respect to an observer, then there is a change in the wavelength of received light or received sound. So in fact, this change is due to Doppler effect. And the top one is has a larger wavelength. That means galaxy is moving away. And if you refer to the lower part where the wavelength is smaller, so you say that the galaxy is moving towards. So you need to include Doppler effect and the change in the wavelength with respect to whether the object is moving away or moving towards. You can rephrase the whole statement as per your understanding, but make sure that you must include the relative motion, Doppler shift or Doppler effect, and if object is moving away, then wavelength is more. Or if object is moving towards, then received wavelength will be shorter. Question number 16, driverless cars are fitted with sensors to map out their surroundings so that they can navigate. A transducer on the car emits a pulse of laser light. The laser light is reflected from nearby object and is received by the transducer. State the factors that determine the fraction of the laser light which is reflected from the nearby object and received by the transducer. So factors on which the reflected laser light or reflected light depends. Clearly it depends on number one, size of the object, or how far the obstacle or the object is, that means distance. And there is another factor you can include, which is absorption factor. When the laser light is emitted from the car and it is traveling towards the object, then in between we can have some absorption factor. That means we can have a humidity, we can have a fog, or some water vapors that can affect this reflection of laser light. So these three you can include. Part B, the duration of pulse of a laser light is 5 nanosecond. This is time. Determine whether this allows object as close as 1 meter from the car to be detected. So the idea is, basically we have a transducer and some object, and transducer emit the light, it hit and then reflect. So whether this object can be detected or not, it depends on other factor, and then the time. So the laser light that we are using has a time duration is 5 nanoseconds. So first what do we do? Using that time, we need to find how much distance can be detected, and if this distance is less than this, that means this light is suitable, and this distance is more, so it will not be suitable. So let's use this 5 nanosecond to find the distance. And remember, this is not just ordinary situation, this is pulse and echo. Pulse echo. So the equation to find the distance is S is equal to UT divided by 2. So U is because we are using laser light, which is electromagnetic radiation, so 3 into 10 to the power 8 into time is 5 nanosecond. 5 into 10 to the power minus 9 nano divided by 2. And if you solve this, then you have answer of S that can be detected by this in this time duration, and this distance is 0.75 meter. Clearly this distance is less than 1 meter. So of course this distance is far, so this is suitable. So yes, indeed, the object can be detected. The object can be detected. Ultrasound would also be reflected from the objects around the car. However, ultrasound travels at much slower speed than laser light, suggests why the laser light could not be replaced with ultrasound in driverless car. Ultrasound has a low speed, so of course ultrasound will take more time during reflection, and in this time interval the car might hit the obstacle or object, so ultrasound is not suitable. Question number 17. A liquid level sensor uses a plastic prism, a light source and a receiver. This is a plastic prism, light source, and the bottom we have a receiver here. An important thing in this question is these angles of the prism, 45 and 45. When the light is below the level of the prism, the light totally internally reflects to the receiver as shown. So light is coming from light source, and totally internally reflected, and then again totally internally reflected and arriving at the receiver. Now describe the condition required for total internal reflection. A typical definition, the conditions for total internal reflection. Number one, the first condition is we should have a refraction from denser to rarer medium, from denser to rarer medium. This is the first condition. And incidence angle is greater than the critical angle. So this is the second condition. Because refraction from rare to denser, we cannot have a total internal reflection. Instead of denser or rare, you can use from high refractive index, medium to low refractive index. And yes, the second condition, incident angle must be greater than critical angle in order to observe total internal reflection. Part B, the critical angle for light traveling from plastic to air is 42 degree. Explain why the light reaches to the receiver. Clearly, if you see the diagram, this angle is 45. That means the light from the source, when it hit this the first side, and if you figure out, use your geometry, then this incident angle will be 45. That means the incident angle as the first phase is 45, which is greater than 42 degree. So incident angle is greater than the critical angle. 42 is critical angle. That means at the first phase, the light is going to be totally internally reflected. When the light after total internal reflection reaches at the second phase, again you see the 45 degree angle. And if you measure the angle here, so this is the incident angle at the second phase, which is also 45 degree. So again at the second phase, you have an incident angle is greater than critical angle. So again you have a total internal reflection. So the light is going to reach at the receiver. Part C, when the liquid surrounds most of the prism, the light does not reach the receiver. Calculate the critical angle for the light traveling from plastic prism into the liquid. Velocity of the light in plastic is this, and velocity of the light in liquid is this. We need to find critical angle, C. Okay, the idea is, because we are not using air, there is the most common mistakes students generally do. Looking at the critical angle, they immediately think that we can use sine C is equal to 1 upon n. Remember, this one we use because of air. If the second medium is air, in case of critical angle, but here we do not have air, so we cannot adopt a direct this formula. So we have to use something else. Now we are using two different medium. So if you recall, for two different medium, it is a general concept that suppose we have a one medium and the ray of light is coming. This is the incident ray. This is the normal, you can think. This is theta 1. And then it is going to bend away. I am considering from denser to rare. This is theta 2. And this is medium 1 of refractive index n1. This is medium 2 refractive index n2. Now we have a relation between these two refractive indices and these angles. So we can say that n1 sine theta 1 is equal to n2 sine theta 2. Same relation we can write about by using speed of light. So sorry, not just light, any speeds of light in any medium. So n1 v1 is equal to n2 v2. Now clearly, if you rearrange this first equation as the ratio of n1 and n2, so you say that sine theta 1 is equal to sine theta 2 will be equal to n2 upon n1. And similarly, if you rearrange the second one, so v1 upon v2 would be equal to n2 upon n1. That means sine theta 1 divided by sine theta 2 is equal to v1 upon v2. And now, because we need to find critical angle, so theta 1 is critical angle and theta 2 must be 90-degree angle. And we have a v1, this is v1 and this is v2. And you substitute the number here, and if you put the numbers, then you can have sine c upon sine 90. So sine c divided by sine 90, which is 1, is equal to 2 into 10 to the power 8 divided by 2.3 into 10 to the power 8. And then if you solve this for c, so c would be equal to 60.4 degree. So c is equal to 60.4 degree, or you can round it off to 60 degree. This is the critical angle. You do not need to show all these working. If you are okay, then you can directly write this. This is sufficient. There is another technique that we can use this approach, but we have to think a way that we need to replace this air with the plastic. Sorry, not plastic, but instead of it, so we use NW, refractive index of water. So first we find refractive index of water, and then we can use this for sine c, but it will take longer than this approach. Sketch the path of the ray of light at the plastic liquid interface on the diagram above. So this is the diagram, and you need to sketch the path of the ray for this interface. So of course, because you know that because we have okay, so indeed you must understand that this is the normal line, and then it will bend away from the normal. So you draw the normal line, and then you can have a refraction in the water. Part D. A storage tank may be used to store wastewater for house. Such a tank is usually located underground. If a storage tank becomes full, wastewater can leak into the surrounding ground and pollute drinking water. Suggest how the liquid level sensor could help prevent this problem. Yes, indeed, you know that if this region, this is the tank, if this tank is empty, that means we have a total internal reflection, and then the ray is totally internally reflected and reaching to the receiver, so everything is fine. But when the tank is full, then there is no total internal reflection, and the light will not be reaching the receiver, and then receiver is is not receiving. It will be connecting with some external circuit of buzzer or siren or whatever external circuit can be, and this circuit can inform or can warn homeowner that there is some overflow of the tank. I guess you must replace the word transducer with receiver, because this is not a transducer, this is a receiver of light. So make sure that you correct this word. Replace transducer with the receiver. Question number 18. The following circuit was used to investigate how the current through a filament lamp varied with time from the moment the switch was closed. So we have a resistor 5.1 ohm. Remember, this is a fixed resistor, a filament bulb we are investigating. We have a data logger and the 9-volt power supply. Explain how an increase in temperature affects the resistance of the filament lamp. Again, this is a typical question of resistance of a filament lamp. So resistance mainly depends on temperature, especially for filament lamp, directly proportional. It's just a relation to say. And why is that? When temperature is increased, so because filament lamp made of metals, high resistance metal. So when temperature is increased, then the atom in filament oscillates with the larger amplitude, and that larger amplitude causes more collision. So collision increase, so current is decreased. That's why resistance is decrease. Sorry, resistance is in current decrease. That's why resistance is decreased. So temperature increase, collision, these are the key. Collision also increase. So amount, due to increase in collision, amount of current is decreased. So that means resistance has increased. So that this flow can help you to understand how to write all the points. Part B, the graph below shows the variation of potential difference across the 5.1 ohm resistor with time. The time at which the switch was closed is marked with an arrow. This is the time. Explain why the shape of this graph also represents the variation of current through the filament lamp. So the meaning of this question is, if you plot current and time graph instead of voltage and time, this graph also have a same shape, and you need to explain why is that, why we have a same behavior. The reason is because we are using constant resistor. This 5.1 ohm is a fixed or constant resistor. That means according to V equal to IR, R is constant and Ohm's law says V is proportional to I or I is proportional to V. Both are proportional, so they have a same behavior. That's why the shape or behavior of current will be as same as the voltage one. Calculate the resistance of filament lamp at the moment the switch is closed. Okay, so this is the shape from a graph that we need to use. First of all, we are going to find the amount of current in the circuit. So this is the voltage when the switch is closed, and if you read that number, this is 1 divided by 5.2, so 4.8. So 4.8 volt. Now you can use I is equal to V upon R. V is 4.8 divided by R is 5.1, and then amount of current will be 0.94. So 0.94 ampere is your current. So now we need to find resistance of the filament. So resistance of the filament RF would be equal to voltage of the filament and divided by current, because if you see the circuit, current will be same, 0.94 ampere. The only thing is we need to figure out VF. And if you see the circuit diagram, if you go back, they are in series, so current is same, but the voltage will be divided. Now from graph we figure out this voltage is 4.8. That means the voltage across the filament bulb will be 9 minus 4.8. So you can say that this VF is 9 minus 4.8, which is 4.2. So VF is 4.2 divided by 0.94, and resistance of the filament lamp is just a symbol. Resistance of filament lamp will be equal to 4.46 ohm, or you round it off till 4.5. So resistance of the filament is 4.5 ohm. Calculate the rate of transfer of energy by 5.1 ohm resistor immediately after the switch is closed. So straightforward, easy, 2 marks. Your rate of transfer of energy, that means you need to find power. Resistance given in terms of in electricity, power is found if resistance is given, and we have already found the current, so we can use P is equal to I square R. So I is 0.94 square into resistance 5.1, and then you can solve it for power, and then you can say that power is 4.51 watt. This is the power. Explain why it is reasonable to assume that this filament lamp reached a constant temperature after 180 millisecond. So if you see the shape, that after 180 millisecond, and now if you clearly see before 180, the graph is gradually decreasing, but after 180 the graph is supposed to be, or is it seems to be horizontal. So that means after 180 second voltage remains constant. So again voltage constant, so that means current is constant, because voltage is proportional to R. That means resistance is constant. So that's how you can say. Explain why a data logger was used for this investigation. So data logger, first of all, because we are observing the time of just switch on, which is a very small interval of time. So there's a very small interval, so of course there will be no reaction time, because it is difficult to read the voltage when you turning on and turning off the switch. So we can eliminate reaction time. And then data logger, because this time interval is very, very small in milliseconds that we cannot see, so we can have a more data point and more plotting point in this small interval. So voltage in the small interval, in that small interval, can also be calculated using data logger. Thank you very much. I hope you understand. All the best. Have a nice day.